I am also in the REGINA project, and I would like to show some results of our long-term experiments in Ljubljana, which we are working with the Slovene Society for Conservation Agriculture, Slovensko združenje za ohranitveno kmetijstvo. We have now around 100 members, 80% are farmers, and the farmers who are seeking to work in a new way, in a sustainable way, and with them we established the society in 2016, and now we have lively discussions, and we are going to present some of the results in our agricultural fair in August this year, and I will invite you to be there as well. So, regenerative agriculture, we heard a lot about it. I will not take my time to speak a lot about this, but some highlights. So, there's a European Union program from farm to fork and biodiversity, and we have to achieve all those goals, to reduce the losses, to use less foreign inputs into the system, and how to do it. This is the question now. And so, as we heard, it's not just that we are doing the things in a way to sustain the system, but we have to improve it, and we are seeking the way to do it. So we are speaking about regenerative agriculture, and here is always have to stress it's we have to take into account different levels. So from the plot, from the soil to farm and to agricultural landscape, and the practices we practice must be adapted to local circumstances. And another thing is that the soil is changing very slowly. So this is hard to see and to take into account, that we can observe the real change in the soil maybe in 30 years. And if we are doing in the wrong way, then it's very hard to improve it, because we were doing in the wrong way for 30 years, and now we are stuck in a problem, and how to repair it. It takes another 30 years going back, and this costs a lot of money and dedication. So it's fine if we would know to follow some of the basic principles. And what are the basic principles? We start from the soil. So the soil is the base for agriculture, and if we take the care for the soil, then we are in the right track. And when we start to take for the soil, the whole system is changing, not just the soil. That's why we are talking about the conservation agriculture. It's not just tillage. Sometimes it's a misunderstanding that it's the change of the tillage and then that's it. But no, it's the change of the system, because if you want to change the soil, you are thinking about the life in the soil. This is the basis, the life in the soil and living organisms. And this is the thing we should think about it, not just nutrients and pesticides and tillage. But yeah, of course, we have to reduce the mechanical disturbance of the soil. That's why we are reducing tillage. Again, to improve the life of the soil living system. And we have to increase the organic matter, and the soil should be covered with plant residue to reduce the impacts, harsh impacts of rain and sunburn and erosion and so on. So at least 30% of soil should be covered optimistically or optimally all over the year. The best would be with the living plants. We know that the living plant, through photosynthesis, put nutrients through roots during the growing season to microorganisms. And this is the most important source of food, not the straw on the field, but the exudates are more important than the straw for feeding soil food web. And of course, we have to improve crop rotation, which we are going to hear afterwards from Marco Napoli. And this is really important to increase the biodiversity of the whole system. So this is in Slovenia, I'm sorry for that, but you will see that here in this crop rotation, after maybe harvesting of wheat and sowing another maize crop, it takes 5 to 9 months that the microorganisms are again fed by exudates. And this is not a good system, even though the soil is covered with plant residue and in this way protected from erosion. But this is a starvation period, and that's not good for the soil. So we have to think about crop rotation very much. Okay, I will go now to some of the results of our long-term experiments. All those experiments are done by farmers, so it's not just university, but also the farmers are involved. And we have different soil types, heavy soil, light soil, and in some experiments we are comparing tillage. Mostly this is a comparison of tillage. So we are doing minimum tillage, shallow tillage of 10 centimeters deep with disc machine of 4 rows. It's a special machine. And of course, we have plowing to compare with this shallow tillage. And from 2016, 2017, we started no-till as well on some of the plots. So the yields are normally, you see this from one experiment, but it's quite the same with the rest of the experiments. The yields vary, and on average now in this field we have 10% less yield with minimum tillage compared to plowing, and the variability coefficient is not so high as 8% in this variation between the both. But you can see in the last years there's a decline because we changed, we got the project and we changed the system to organic without herbicides. And this is then observed immediately. We cannot do, we don't know how to do it without herbicides, minimum tillage. So plowing is really a natural or non-chemical way of preserving the soil to be infested by herbicides in our climate, because we have a warm climate with a lot of precipitation, and there's explosion of thermophile weeds in end of July, beginning of August. And they grow so fast in 14 days are so high. So if you cannot intervene with mechanicals or proper herbicides in a proper time, then we have problems. But on the average, the yields are quite okay with herbicides. And after 20 years or something, there are different experiments. The first one started in 2011, the second one also in comparison heavy soil and light soil in 2011, so 12 years. And you can see the difference is in sea arc is happening in the first 10 centimeters, of course, also in the first centimeter. And the difference is compared to plowing, this O is plowing, is 0.4%. Not so much, we would say. Just 0.4, and is it significant? But it's in a margin of significance, because there's large variability of soil organic carbon within the field. And it's very hard to get a significant difference in scientific terms. So we said, okay, that's fine, 0.4, not so much, but we were happy with that. But you will see after, when we calculate to mass, to tons per hectare, that's not insignificant. That's a large difference. And with the longer term experiments lasting from 1999, the difference is larger. Maybe, again, not so much in light soil. In heavy soil, we have here using compost as well. This orc is compost. The difference is more pronounced. When we calculate for this light soil, for example, the quantity in upper 20 centimeters in tons, the difference is quite significant. So plowing 37 tons, no-till upon minimum tillage was until 2016, and no-till is from 2016 until now, is 54 tons. So the difference is really huge, and this difference is organic carbon, not organic matter. So the difference is 17 tons. 17 tons of carbon. It would mean approximately the energy of 17 tons of oil, crude oil. So imagine if you would put into a burner 17 tons of crude oil. There's a lot of energy. And this energy drives the system in the soil. This is the energy for microorganisms. This is the food for microorganisms. And this is, of course, the energy for transformation of the soil. Again, when we measured the CO2 emissions from this experiment in Ljubljana, we see that in a no-till system, we have in NPK and compost around 600 kilograms per year less emitted carbon per hectare. So 600 kilograms per year was retained into the soil in comparison between two systems. And this is the carbon stocks. In Ljubljana plowing system, this one 2 years, and this one is no-till, and here we have different fertilization. So control without fertilization for more than 20 years, mineral fertilization, and mixing of mineral and compost. And of course, the compost build-ups organic carbon very high. But even mineral fertilization in comparison to tillage is much higher, especially in the upper 10 centimeters, so that the average differences after 24 years per year was 840 kilograms in minimum tillage compared to plowing. So that's a lot. That's really a lot. And we are wondering, is this really sustainable? Because when we build up organic carbon, we put energy into the soil. And this energy is food, you know, and soil is organism, and every organism needs a certain amount of food. If you eat too much, then there's a problem. You get gases and diarrhea, maybe, if it is fed too suddenly, of course. But this is just getting fatter. And with this with system with more energy in the system, we have to be more careful. When we put mineral nitrogen, we can get emissions of N2O or leaching when there is no good correlation with the needs of the crop, with the input. So with this system, crop rotation becomes more crucial, and fertilization must change. So we have to take care when we put nitrogen into the soil, very much. much more than in a system which is poor. This is some measurements of microbial biomass. It's very much follows the pattern of increasing carbon in the soil. When you have more carbon, you have more microbial biomass in the soil. This is normal. And also, it's interesting, the availability of phosphorus and potassium enhanced substantially. With the same fertilization, we are now on the level of extreme values in no-till and min-till, especially in light soil. In plowing, we are still in the optimal level. So how to put in now, how to advise farmers, should they stop putting phosphorus and potassium in these fields? We don't know. We need further investigation in this direction. Yeah, it's in every field is quite similar. So very high levels of available nutrients when the microbial life is enhanced. So when microbes and other organisms in the soil are active, then they release the nutrients from the reserves into available form. So to conclude with some findings. So with minimum tillage, no tillage as increasing trend in soil carbon stocks, and in plowing there is no difference or it's declining. Depends on the system, depends on the crop rotation, on the plant residue and so on. The stocks are getting higher faster in heavy soil. This is also to be expected because the organic matter is bound to clay particles and the microorganisms are having problems to get it in such circumstances. And there's more microbial life, not just in total terms, also abundance of different strains are seen, and we have now 4 PhD works in our department are running in this experiment, so we have a lot of data, more in deep. Yeah, we have to take in mind that the soil is very heterogeneous and it's very hard to get significant results in a short term. So we have to observe the soil in a long term, 10, 15, 20 years, then we see the difference. And it's also very important to tell the politicians not to support one-year programs. Support a systematic approach, a long-term commitment to those farmers who want to do that, not to everybody. So we need the group of champion farmers who seek this, who try to understand it, who are committed to do it, and they should find their own way. So prescription by the government how to do it is wrong. Every farmer should find their own prescription. Yeah, and better supply of nutrients. Yeah, this whole system is changing. Not just tillage, not just crop rotation, fertilization, using of herbicides, and it's very much locally adapted. Yeah. So yeah, thank you very much. You see, the Slovenia is much different than Ireland. We have very small fields, small farmers, and that's a problem. How to do economically in such small fields? We cannot take cattle around the village to graze the things on the fields because it's logistically difficult. But it's a quite picturesque landscape, and you're very much invited to visit us.